All right, CNT125, Chapter 7. We're now to the section on virtualization. So virtual architecture. Virtualization is that. It's a virtual representation of a physical entity. Once upon a time, if you needed multiple servers, you literally bought physical servers. I need a new server, I bought another physical server. You need another server, I bought another physical server. Nowadays, if you have it needs to be a pretty robust server, you know, plenty of RAM, plenty of processing, plenty of storage. You can actually have multiple virtual servers on it. So you might have one physical box there, connecting to your network, connecting to battery backup, you know, redundant NICs, etc. But I could have on there 3, 4, or 5 virtual servers doing maybe very specific tasks. That is virtualization. So a host is a physical computer that hosting the virtual machine, so my server, if you will, and the guest is each of the virtual machines on top. And all this is controlled by a hypervisor. The hypervisor creates and manages each of the virtual machines. So I might have a physical machine here, and I might have, you know, the hypervisor loaded on top, and then 2 virtual machines in there. For us users, for us students, if you will, once upon a time, if I wanted to have more than one operating system on my computer, I would literally need to partition my hard drive, create a boot partition, carefully load my operating systems, and then on boot up, I would select the portion of the hard drive I wanted to boot, and in effect, the operating system I wanted to boot. That was common for a lot of us to do, especially the early days of Linux. I literally partitioned my hard drive, put Red Hat Linux, I guess it was 7 in those days, on one partition in Windows. It was probably XP in those days, and the other partition. And on boot up, I would choose which one I wanted to boot and work with. Very common, but also could be very problematic. There were times I have wiped out hard drives because I got the install wrong. I didn't pay attention to something. Well, with virtualization, I can have a host PC, and I can have 2 or 3 virtual machines running inside. You know, I might have my host PC, like this one, maybe running Windows 10, and inside have a virtual machine running Linux blah, and maybe a Linux blah in there, or maybe even a virtual firewall that I'm working with. So very handy for us. There are 2 types of hypervisors, Type 1, Type 2. Type 1 installs in the computer before any OS is installed. This is called a bare metal hypervisor. These would be things like ESXi by VMware, Hyper-V. There's a Hyper-V by Microsoft. There's even Linux KVM. This would be the kind if you have a server in a server closet and you want to put virtual servers on top, a physical server, you want to put virtual servers on top, typically what you're going to install in there. The Type 2, this installs on the host days as an application. So if I have a Windows desktop and I want to install a Linux virtual machine inside, I would install your Type 2 hypervisor. This would be like VirtualBox, VMware Player, Client Hyper-V, that I would install my virtual machine into. And there is a Linux KVM that's also made for this as well. So some of these, they basically have pieces for each one. So here is, you know, ESXi, your bare metal hypervisor, that's installed, and then your VMs sit on top. Your VMware Player, your Type 2, I actually have the host operating system. Maybe it is Windows 10, and then my hypervisor goes on top, and then I have my VMs inside, you know, my Linux virtual machine or whatever. That would be your Type 2. That's the kind we'll be doing in our lab room. We'll be installing that in our lab room. Here are a couple of the big players, just getting a couple names out for you. These are all big players in virtualization or hypervisors, just for name recognition. If you look at market share, these were numbers I grabbed at the very end of 2022. You see that some of the big players, VMware vSphere, Microsoft Hyper-V, VMware ESX Server, these are some of the big players in the market share. There's a lot fall in the other, but these are the big players in the, the overall, if you will. So, your virtual machine software and hardware characteristics are assigned when you install or set up the hypervisor. So when I'm installing my virtual machine, I literally allocate any of these pieces over here, how much memory, how much storage that I'm allocating to my virtual machine, usually in some kind of slider fashion. the thing you need to remember is, and again, you can customize the amount of storage, the amount of RAM, etc. that you're allocating. You do need to remember that the more I allocate to one, the less something else has. So if I give my virtual machine a lot of memory capability, maybe the host OS has less now. So it is kind of like I do have to manage and make sure I don't oversubscribe one and not have enough for another one. That is something I need to keep in the back of my brain. But during install, that's where I set all that. And we'll do that when we build our virtual machine. Also, when I set up my virtual machine or virtualized system, if you will, I have to worry about the type of network connection it has. Each virtual machine has its own virtual network adapter, VNIC, if you will, that's going to connect the virtual machine to the physical NIC on the host and then out to the network. Your VNIC operates at the data link layer, provides a computer with network access. Each virtual machine can have several VNICs too. So I have the host. I have the host machine has its NIC, and typically what happens is, I think I have a picture on the next page here. Here's the actual physical NIC of the machine. The hypervisor basically puts the equivalent like a virtual switch in here, and all the virtual machines on there connect to it. So I can have a whole bunch of virtual NICs with my hypervisor connecting into this virtual switch, connecting to the physical NIC on that device. So anytime I'm building a virtual machine, it's basically allocating a virtual NIC. Oops, I think I'm going the wrong way. Here we go. Okay, there we go. The maximum number of VNICs really depends on the hypervisor. Sometimes this might only be 8, basically 8 virtual machines. Each of these VNICs is assigned a MAC address. So each one of these, if I were to do like an IP config on them, if you will, or ifconfig, is going to have a MAC address. The beginning of that MAC address will be by the hypervisor manufacturer. The beginning of that MAC address will be similar for that manufacturer. That manufacturer will be using the same beginning on all those. So if I take a look here, here's my network adapter. Over here I can set the settings for that, the type of network connection it has. So let's look at the types of network connections we have then. Okay, and I mentioned the switch there, and this is the V switch, and the hypervisor controls the V switch, and I think I even showed that here. Yep, your hypervisor has this virtual switch in here that all the virtual NICs are attaching to. So just keep that in the back of your brain. And I can actually, if I have two physical NICs in my device, I can literally have this. I have a couple virtual NICs attached to this NIC and a couple virtual machines attached to this NIC. So if I'm dealing with a server with two NICs in, I can have a couple client, a couple virtual machines connecting to one physical NIC and a couple virtual machines connecting to the other physical NIC. You can allocate that. When I set up this virtual machine, I have to identify the type of VNIC connection it's going to be. There's bridge, NAT, and host only. So we need to recognize what those are and pay attention when I install my virtual machine as to the setting it's going to use. In bridge mode, the virtual NIC accesses the physical network using the machine's NIC. So it's going to obtain its own IP default gateway network mask from the physical LAN. So it's actually going to look like another node on the network. So here is the physical NIC on the machine. It's getting a 192.168.1.131 kind of thing. If I set my VNIC to be bridged, it's acting like it's another NIC out here on this network. It's going to get another IP from that same network, 192.168.1.133. So it's going to act like it's a node on this network, almost like it's connected right here to a switch port. So with bridge mode, it's literally bridging it out to the network as if it's a node on that network. For most of what we're going to do in our labs this semester, we use this mode. Okay, this is the mode we typically use. And as I install on my virtual machine, I'm looking for bridge mode. Somewhere I'm looking for bridge mode to set that. With NAT mode, the virtual machine, the hypervisor, is going to act as the NAT, if you will. Whatever IP address it has, it's going to NAT it to the virtual NICs. And the hypervisor is going to act as like the DHCP server for that virtual NIC. So in this case, again, the physical NIC's getting the physical host, if you will, is getting a 192.168.1.31. It's going to NAT that into its own private scheme in here. We're seeing a 10. and it's going to hand those 10s out to all the virtual machine NICs that are in here. So each one of these are getting a natted address, 10.blah, blah, blah, blah. So this is now hiding behind the actual physical NIC. As we see here, it can communicate with the other nodes, but it's basically invisible to other nodes on the physical network. It can communicate out, but communicating in can be a problem. We typically don't use NAT mode for the lab kind of things we do in our lab room. The last one is host only. With host only, only the virtual machines can communicate with each other inside of that hypervisor. They're not going to communicate out. They can't communicate out or can't communicate in. So this typically gets used when you're developing, maybe building up a server. Let's say I'm building up a new server and I don't want it responding to requests from the network. I put in host only while I'm building up and getting maybe the features and everything set before I turn it live onto the network. So here, as you see, there's really no connection from the physical NIC into these devices in here. So these two virtual machines might be able to talk to each other, communicate with each other, but they're not going to communicate out to the physical NIC and the network. So that's your host only mode. So with host only mode here, you see host only there as your selection. There's no labs that I have you set this as host only. There's no labs that I have you set this as host only, but it is useful for development purposes. It is useful for that. As I look at some pros and cons for virtualization, as we said early on, there's some efficient use of resources. I can have one physical server handle 3 or 4 virtual servers, and that cuts down on the physical cost. It also cuts down on the cost and energy savings. I'm only powering one physical server as opposed to 3 or 4. And for that matter, only cooling one server as opposed to 3 or 4 servers. There is some fault isolation. It's to that box, if you will, and it's a little more simple to back up and recover and replicate because it's all contained in that one unit, if you will, and I can replicate that virtual server and back that up, and I literally can have that move to another server and gen right back up. Disadvantages, though, is I can have compromised performance. As we said, when I'm allocating those virtual machines, if I don't adjust that memory correctly, I could be robbing some memory from another virtual machine that's going to slow down its performance. It is more complex to manage. As you see when you're installing this, there's a lot of things you could get wrong and not work correctly. So there's a lot more things to configure. I'm not free of licensing costs. I can't keep installing servers on here free of charge. I literally need to have a license for each one of those I put on there, just like I would a real box. And I do have a single point of failure, because if that physical server that we're working on fails, all the virtual machines on there are going to be out of commission. So there is some single points of failure with this. So like anything else, pros and cons, those are things to keep in mind. All right, we'll come back in the next one and talk about network functions virtualization.